All right, guys, here we go. Here's the kinematics lesson number 4, example problem 3. Here's how we solve this one. Vertical motion now. It's just like horizontal motion, same process, just up and down. The ball is dropped from the top of a building that's 80 meters above the ground, ignoring the effects of air resistance. Determine the time it takes for the ball to reach the ground and determine the speed of the ball when it hits the ground. Again, I always like to keep the equations handy, so I'll just write them up top here, right? Same equations as always, or 3 kinematics equations, if I can write them. Why can't I get the pen to write? Vf equals Vi plus At, or change in position equals Vit plus 1/2 At squared, or Vf squared equals Vi squared plus 2Ad. Those are your equations. You can keep those around. Process is always the same. First, draw a picture. A ball is dropped from the top of a building. So here's our building. And we'll add some windows. There's a window, there's a window, there's a window. And down here is the ground. And here's the ball being dropped from the top of the building. Okay? And it's going to go to the bottom. Now, there's our building. Same process. D, T, V. We'll call this position 0. We'll call this time 0. And it's dropped. So it starts from rest. At some point, the ball is going to get down here. When it does, we'll have a change in position. It'll have fallen 80 meters. How long will that take? We don't know. And what speed will it be? We don't know. That's hard. We have to figure out the time and we have to figure out the speed. But we do know something. While this thing falls down, while this thing is falling in the air, at some point the ball will be here. And if we were to draw a free body diagram on it, the only force acting on it is weight. There may be some frictional force, air resistance, but they say ignore air resistance. So because of that, we can then get rid of this. There's only one force acting on it. If there's only one force acting on it, the acceleration through this whole time is ma, the net force, right? The acceleration is minus 9.8 meters per second squared. That minus means down. All right. So now it's the same process. We got our DTV, we got the acceleration on that trip. Here's the acceleration. And if you were to use 10, you wouldn't get it wrong. You'd be fine. But here we go. I don't know why I used 9.8. Let's think. First equation, Vf equals Vi plus At. We don't know Vf, we don't know T. Not much we can do here. We could get Vf equals initial velocity is 0 plus negative 9.8 meters per second squared. We need time to figure out Vf. All right, so we need another equation. What else could we do? What's the next one? Change in position equals Vit plus 1/2 At squared. Change position. It starts at 0. It drops 80 meters. It's going to lose 80 meters. Its initial velocity is 0. We don't know the time there. Plus 1/2 acceleration, negative 9.8 meters per second squared times time squared. What's so very, very cool here and what's so very, very useful is that this part vanishes. Vit, if it's dropped from rest, that vanishes. So you just get minus 80 meters equals 1/2 negative 9.8 meters per second squared times time squared. Minus 80 meters equals negative 4.9 meters per second squared times time squared. Divide both sides by negative 4.9 meters per second squared. This you get 80 divided by 4.9, 16 point something seconds, 16.3232, blah, 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 seconds squared equals t squared. Take the square root of this, take the square root of that. You're going to get 4 seconds equals t. Well, that makes sense. Should get time. You really get 4.04 seconds. Close enough to 4 seconds. You come back to there. Now you know VF equals 0 plus negative 9.8 meters per second squared times 4 seconds. That's supposed to be a 4 seconds. And you're going to get the final velocity to be 39.2 meters per second. Time, 4 seconds. Speed, 39.2 meters per second. If you were to do all of that with 10 instead of 9.8 or negative 10 instead of negative 9.8, you'd end up with 4 seconds and 40 meters per second. You'll be fine. That totally works. All right.